Next we have work energy theorem. So what is the definition of work energy theorem? Work energy theorem states that increase in kinetic energy of a moving body is equal to the work done by a force acting in the direction of moving body. What does it mean? Carefully see. For example, a body is moving with some initial velocity. Okay, it is having some initial kinetic energy. By applying a force, we are increasing the speed of that body. So when we are increasing the speed, we are doing some work done in increasing its speed. So that work done is equal to change in kinetic energy or increase in kinetic energy. Now let's understand with the example. For example, a ball is moving with some velocity, initial velocity u. After applying some force, its velocity will increase. Okay, so it become v. Okay, so initial velocity of this body is having u, final velocity we have v. And kinetic energy, if I am talking about, initial kinetic energy of this ball is having half mu square. By applying some force, its velocity will increase. So final kinetic energy we got it as half mv square. So how much is the increase in kinetic energy? So increase, if I am talking about increase in kinetic energy, we have final kinetic energy minus initial kinetic energy. Final kinetic energy we have half mv square minus initial kinetic energy we have half mu square. Now let's calculate the work done in this case. So here we are applying some force which moves a body to cover some displacement s, okay, by producing an acceleration a. So F we have force apply, we have mass into acceleration. So work done in this case we have force into displacement. Force we have mass into acceleration, and displacement in this case we have s. Okay. Now from the equation of third equation of motion, v square minus u square is equals to 2as. V square we have final velocity as v square, initial velocity u square, 2as. So from here let's calculate the value of displacement as v square minus u square by 2a. Now put the value of displacement here. So mass into acceleration, v square minus u square over 2a. So cancel it out. We got as 1 by 2 m v square minus u square. Now multiply. Work done we got it as 1 by 2 mv square minus 1 by 2 mu square. Now carefully see. This is the work done to increase the kinetic energy, and this is increase in kinetic energy. Have you seen any correlation? These are both equal. It means that work done on a body to increase its kinetic energy is same. So increase in kinetic energy of a moving body is equal to the work done. Increase in kinetic energy, which is final kinetic energy minus initial kinetic energy, is equals to the work done which the force is doing to increase its velocity, otherwise increases kinetic energy. So this whole thing is actually a work energy theorem. Clear? So this is the expression of work energy theorem, in which work done on a body is increase in kinetic energy. Increase in kinetic energy here, half mv square is final kinetic energy and half mu square is the initial kinetic energy. And final minus initial kinetic energy is increase in kinetic energy, which is equals to the work done.